Hey there. Turn up my volume. I can't hear. We are in Unit 1, Lesson 13 in Algebra 1, still talking about statistics and a little bit more on standard deviation. Okay, so let's talk a little bit about outliers. I know this is a warm-up. Evaluate mentally. Okay, so let's evaluate these things mentally, but then we're going to sort of talk about what they mean. If I go here, so this is 0.5 times 30. You don't need to get your calculator out. This is really half. This is 0.5 means half, right? Half times 30, which half of 30 is 15. Now, if we know half of 30 is 15 and it's 1.5, it's really like a whole plus a half. That's 1.5. A whole plus a half. So a whole 30 plus half of 30 is 45. Now 100 minus 1.5 times 30, so that's 100 minus 45. That's going to be 55. Okay, and then 100 minus 1.5 times 18. PEMDAS tells us to do this first. So 1.5 times 18 is a whole 18 plus half of 18. So 18 plus 9 is 27. 100 minus 27, I know it says mentally, and that's fine. I really like writing things down. So I need 3 more to get to 30. And then, so there we go, 73. Okay, now why are we doing this? Rather than do that, we're going to talk about this a little bit. I'm going to change to a much happier color. Let's go funny color blue. We're talking about outlier math, and we're really doing like A minus 1.5B. And I wish I could get rid of that yellow dot. I don't like that yellow dot. I don't know if you guys see that yellow dot. This will be useful when we talk about our Q1 minus 1.5 times the IQR. Remember the interquartile range? And that is going to determine if values are outliers. Determine okay? So Q1 minus 1.5 times the IQR is going to help us determine if values are outliers. And that will make better sense here in a little bit, okay? A little preview. All right, this next thing, I actually just spent some time cutting out some cards to talk about this info gap, African and Asian elephants. So this is our first information gap activity. It takes a little bit getting used to, and we'll spend some time doing this in class together. Yes, so each pair of students, 2 students sitting a bit further apart, will be given a data card and a problem card. So you'll have a data card and a problem card. I thought I had some sitting right here, I don't. So you're both going to silently read the data card, okay? And the data card student will do the questions they see below this in purple. What specific information do you need? Why do you need to know that piece of information? Listen to your partner's reasoning and ask for clarifying questions. Okay, this doesn't have to be done quickly. It's important for our understanding to be able to ask the right questions and answer the right questions, and answer those questions in the right way. So listen to your partner's reasoning and ask for clarifying questions. And then you go back to the top. What do you need? Why do you need to know? And then read the problem card and solve the problem independently. That was you, data card student. Read the problem card, solve the problem card independently. And now share the data card with your partner and discuss your reasoning with your partner. Okay? So let's start at the beginning again. Data card student, what specific information do you need? Why do you need to know? problem card student. We haven't talked about you yet. Problem card student can say things like, can you tell me a piece of information I need? I need that piece of information because. Okay? Share the problem card with your partner and solve the problem independently. Okay? Read the data card and discuss the reasoning with your partner. So you're really working independently and coming together at the bottom to figure out the solution to your problem given the data. So problem card student has the problem. Data card student has all the information, and you're coming together to solve it. Okay? It's kind of fun. And I've got 2 rounds of those. Okay? There's a problem 1 and a problem 2. All right, and it says here, do not show or read your card to your partner. Wait for the questions. Okay, and this you'll be given. Silently read the information. Ask your partner questions before telling your partner information. Ask why, okay, etc. Silently read your card. Ask your partner for information. Explain how you're using the information, and then you guys can solve the problem. All right, so that will be done in class. Okay, now interpreting measures of center and variability. I'm not to the right page yet. Sorry. Still not the right page. Golly, there we go. So here we're going to compare data sets and interpret measures of center and measures of variability. So we're comparing data sets. And determine measures of center. That's a terrible line. Measures of center and measures of variability. So for each situation, you are given 2 graphs of data, a measure of center for each, and a measure of variability for each. So let's practice interpreting the measure of center in terms of the situation, and then interpret the measure of variability in terms of the situation. That means that when you answer the question, you have to use the data that's given to you to answer. Interpret the measure of center in terms of the situation. So you're not going to say the measure of center is 44.8 feet. You're going to say the measure of center is 44.8 feet, which is the average tree height in forest A. That's in terms of the situation, okay? All right, so here for number 1, we have the heights of 40 trees in each of 2 forests are collected. So the heights of 40 trees in 2 different forests. We have forest A and forest B. So we want to interpret the measure of center, interpret the measure of variability in the situation. Do I have room to write? Cool, I do. So there's the problems and there's some room to write. So here, the mean tells us the average height of trees in each forest. Some will be taller than others, right? So that's interpreting the measure of center. The mean gives us the average height of trees in each forest. And to keep on going a little bit, to give more data, some will be taller than others. And then interpret the measure of variability. So this is this one. Oh goodness. What are we doing? Okay, there we go. So the standard deviation, because we have a standard deviation of 4.72 of just the population, is the measure of how variable the tree heights are. Now what's that mean? If we have a larger value, means there are much taller and much shorter trees than average. That got a little messy. Which means that smaller value means they are mostly the same height. Oops. That should be height. All right, I'm going to answer the last question on the next page. And then compare the two data sets. Okay? So here I have a mean and a standard deviation and a mean and a standard deviation. So let's change colors again. Totally out of room. So let's do this. This is going to be purple. And I'm just going to draw up here. Okay, so to compare the two data sets, I have for Forest A a mean of 44.8, Forest B a mean of 56.03. So Forest B has an average height that's taller. So Forest B trees tend to be taller. That would be based on mean. And then if we look at the standard deviation, Forest A is 4.72 and Forest B is 7.87. So higher standard deviation means that there's more variability, because that's what we wrote here. A larger value means there are much taller and much shorter trees than the average, so more variability. All right, so we can say Forest A is more uniform. That's terrible. Forest A is more uniform. Forest B has more variability. Okay, cool. Let's try this one. We use the same colors. You have all the information above. I think I went blue, green, purple. Yep. So blue. So here we have the number of minutes it takes Lynn and Noah to finish their test in German class. All right. So the first graph is Lynn. The second graph is Noah. And the mean tells us the average number of minutes it takes each person to finish the test. And then the standard deviation, we've got 5.44 and 7.40. This represents how variable the data is. Represents the variability. The variability of the times. A greater, say a bigger standard deviation sorry. I know if I write slower, it doesn't mess up as much. A bigger standard deviation means the person finishes much slower or much bigger. Not bigger. Slower or faster, sorry. Oh my goodness, hold on a second. Let's just do this. The drag can be so hard sometimes. I just pushed pause and finished writing. So the standard deviation represents the variability of the times. Bigger standard deviation means the person finishes either much slower or much faster each time than the mean each time, while a smaller standard deviation means the person finishes around the same time each test. So smaller standard deviation means very little variability, larger standard deviation means big variability, okay? And then interpret here. So Lynn finishes in an average time of 29 minutes and 48 seconds. 29.48 minutes, so that's not 48 seconds. It doesn't work that way. But 29.48 minutes, and Noah finishes in 28.44 minutes, so pretty close to each other, right? Lynn's standard deviation is smaller than Noah's, so Noah's going to have more variability, okay? More often, Noah will finish either a lot faster or a lot slower. But Lynn's standard deviation is smaller. That means that her data has less variation. Noah, bigger standard deviation, bigger variation. Lynn, smaller standard deviation, less variation, okay? All right, last one, okay? I'm not going to write everything out this time. You can always push pause and rewind if I've said something confusing. But the number of raisins in a cereal with a name brand and the generic version of the same cereal are collected for several boxes. So our mean means that it's the average number of raisins in a cereal box, right? Average number of raisins in the cereal box for name brand versus generic. Yep, so the first one is name brand, the second one is generic. Now the standard deviation. A large standard deviation means that some boxes had much smaller amount of raisins and some boxes had a bunch more raisins. Okay, a large standard deviation means there's more variation between different boxes. Okay, you're testing a bunch of boxes. It shows how variable the number of raisins are. Small value means the number of boxes tend to be more consistent. A large standard deviation means that there's more variety, there's more variation. So if we look, 289.1 raisins for the name brand, 249.17 raisins for the generic. That means on average there are more raisins in the name brand cereal. Now the standard deviation for the generic is bigger than the standard deviation for the name brand. So there's less variation in name brand, more variation in the generic. Okay? All right. And that was it. All right, let me know if you have any questions, but I think we got that one.